Hello everyone, let's begin a journey. A journey to our sun. It's our very own star, the closest one to Earth. It sits right at the center, the heart of our solar system. The sun is truly huge, an almost perfect ball of gas. This gas is incredibly hot, super hot in fact. Its gravity is immense. This gravity holds everything together. All the planets, asteroids, comets, they all dance around it. It keeps our cosmic neighborhood tidy. A celestial anchor, you could say. The energy from our sun, it's vital for us here, essential for life on Earth. It drives our planet's weather. From gentle breezes to big storms, without the sun, Earth would be different. A frozen, dark, lifeless rock. We owe our existence to it, a constant source of power. So let's explore this star. We'll look at its size, its age, and what it's made of. We'll delve into its structure and the amazing things it does, like solar flares and sunspots. It's a fascinating subject, truly. Prepare to be amazed by it, our brilliant, life-giving sun. Let's talk numbers now. The sun's basic facts. It's incredibly old, you know. About 4.6 billion years. It's middle age for a star, so it has plenty of life left. It's a G2V type star, a yellow dwarf to be precise. Now think about its size. The sun's diameter is huge, roughly 1.39 million kilometers. That's about 109 times wider than Earth. Imagine lining up 109 Earths. That's how wide the sun is. Its equatorial circumference is vast, over 4.37 million kilometers. And what about its mass? The sun is incredibly heavy. Its mass is 1.99 times 10 to the power of 30 kilograms. That's 333,060 times Earth's mass. It's hard to even imagine. The sun holds most of the mass in our entire solar system, about 99.86% of it all. The planets are tiny in comparison. The surface of the sun, it's a scorching place indeed. The temperature there is hot, around 5,500 degrees Celsius. That's hot enough to vaporize metal. Yet this is just its surface. The core is much, much hotter. We'll get to that later. These numbers paint a picture of an immense, powerful star. So, what is the sun made of? It's not solid like Earth. It's a giant ball of gas. Extremely hot ionized gas. We call this state plasma. The fourth state of matter. These gases are under pressure and at incredibly high temperatures. This composition is key to its power. Let's break it down further. The main ingredient is hydrogen, about 70% of the sun's mass. Hydrogen is the simplest element, just one proton, one electron. It's the most common element throughout the entire universe. The sun has a huge amount. This hydrogen is its fuel, the source of its energy, a massive nuclear furnace. The second main component is helium. This makes up about 28% of the sun's total mass. Helium is the second simplest element. It's also very common, especially in stars like ours. The sun is constantly making helium from hydrogen deep in its core. This process releases energy, which we see as light and heat. There are other elements too, but in much smaller amounts. Things like oxygen, carbon, neon, and iron, among others. These make up less than 2% of the sun's total mass. Scientists can tell this by light. Studying the spectrum of sunlight, it reveals the sun's chemistry, a star's unique fingerprint, really. Let's journey inside the sun. It has different layers, you see, like an onion, but much hotter. We start with the core. This is the sun's engine room, right at its very center. It's incredibly dense and hot. The conditions are extreme here. This is where the magic happens. The source of all its power. Temperatures can reach 15 million degrees Celsius. Think about that for a moment. The pressure is also immense. Millions of times Earth's atmosphere. These conditions force atoms together. Hydrogen atoms fuse to make helium. This is nuclear fusion, folks, the sun's energy generation process. This fusion releases enormous energy. Photons, or light particles, are born. They start a long journey from the core to the surface. It can take them ages, millions of years, believe it or not, bouncing around inside the sun before they finally escape and travel out into space, eventually reaching us on Earth. Above the core are other layers. The radiative zone comes next. Energy travels by radiation here. Then there's the convective zone. Here, hot plasma rises, cools, sinks, like boiling water in a pot. This carries energy outwards. Finally, we reach the surface, the visible part, the photosphere. This is what we see from Earth. The sun's surface isn't calm. It's a very active place, full of dynamic phenomena. One such feature is sunspots. These are temporary dark patches visible on the sun's photosphere. They appear darker, it's true, because they are cooler than their surroundings. Still very hot, mind you, around 3,000 to 4,500 degrees Celsius. Sunspots are linked to magnetism. The sun has a strong magnetic field. This field gets tangled and twisted by the sun's rotation. Sunspots form where fields are strong, concentrated magnetic activity. This inhibits heat transfer from the sun's interior, making the area cooler. They come and go in cycles. Then there are solar flares. These are sudden, intense explosions, bursts of energy and light. They happen near sunspots, usually where magnetic fields cross or tangle or get reorganized suddenly. This releases a huge amount of energy across the electromagnetic spectrum, from radio waves to X-rays. Powerful flares can affect Earth, and let's not forget solar wind. The sun constantly blows a breeze, not of air but of particles, charged particles, mostly protons and electrons. This stream flows outwards through the entire solar system, traveling at high speeds, around 450 kilometers per second. It's the sun's magnetic field extending out into space. Our sun is currently middle-aged, about 4.6 billion years old. It's in a stable phase, burning hydrogen into helium. This will continue for another 5 billion years. Eventually, the hydrogen runs low. The sun will become a red giant, engulfing Mercury, Venus, and possibly Earth. After this, it will shed its outer layers, creating a planetary nebula. The core will collapse into a white dwarf, slowly cooling over eons. Earth and the sun are linked, an intimate cosmic dance. The sun is our parent star. We orbit around it constantly. This orbit isn't perfectly circular, it's slightly elliptical and oval. This means our distance changes throughout the course of a year. Sometimes we're a bit closer, sometimes a bit further away. The average distance is key. From Earth to the Sun, it's about 150 million kilometers. That's a long, long way. This average distance is special. It's called an astronomical unit, or AU for short. It's a handy yardstick for measuring distances in space, especially within our solar system. Light from the Sun travels fast, at the speed of light, of course, about 300,000 kilometers per second. Even at that incredible speed, it takes time to reach us. About 8 minutes and 20 seconds for sunlight to travel that 150 million kilometers. So when you see the sun, you're seeing it as it was over 8 minutes ago. This connection is fundamental. The sun's gravity holds Earth in its stable, life-sustaining orbit. Not too close to burn, not too far to freeze. This Goldilocks zone is crucial. The sun's energy dictates our seasons due to Earth's axial tilt. As we orbit our star, our existence is tied to it. The sun's importance to Earth, it cannot be overstated, really. It's our primary energy source, the ultimate life giver for our planet. Plants use sunlight for photosynthesis. This process creates food and releases oxygen we breathe. It's the base of the food chain. All life depends on this, from tiny microbes to giant whales. The sun provides us with light, obvious but so important. It illuminates our world, allowing us to see and to go about our days. Imagine a world without daylight. It would be perpetually dark. The psychological impact alone would be immense for humans. Sunlight also provides warmth. This warmth is crucial. It keeps Earth's temperature within a habitable range. Without the sun's heat, Earth would be a frozen wasteland. Average temperatures would plummet. Oceans would freeze solid. Life as we know it could not possibly exist. The sun makes Earth livable. The sun also drives our weather and our climate systems. Solar energy heats Earth unevenly. The equator gets more direct sun. The poles get less. This temperature difference creates winds and ocean currents too. It powers the water cycle. Evaporation, condensation, precipitation, all thanks to the sun's energy. Let's share some cool facts about our amazing sun. It's truly full of surprises. Did you know its shape? The sun is almost perfectly spherical, one of the roundest objects ever observed in nature. There's only a tiny difference, about 10 kilometers, that's all, between its polar and equatorial diameters. Now consider its massive scale. We said it's 109 times wider than our home planet Earth. But what about volume? You could fit many Earths inside a hollowed-out sun, approximately 1 million in fact, more precisely around 960,000 if Earths were perfect spheres, or 1.3 million if squished in. The sun's surface area is also mind-bogglingly large. It's about 11,990 times the surface area of Earth. Imagine trying to explore that. It would take a lifetime, many lifetimes actually. The sun is just so vast, it dominates our solar system in every conceivable way. Here's another interesting tidbit. The light energy from the sun, it reaches Earth in minutes, just over 8 minutes, as we said. But that energy's journey from the sun's core to its surface takes an incredibly long time. It can take millions of years for a photon to make its way out, bouncing around inside the dense star. So we've explored our sun from its fiery core to surface, its statistics, its phenomena, and its incredible life cycle. It's clear the sun is vital. Not just a pretty light in our New Zealand sky, it's the heart of everything, the central pillar of our system, a star among billions. The sun's energy sustains us. It fuels life on Earth. It drives our weather patterns. It provides the light and warmth that make our planet habitable. Without our sun, there's no us, no trees, no animals, no oceans, just a cold, barren rock. Its influence is profound, shaping everything around us. Its gravity holds us together, keeping planets in their orbits, a cosmic ballet perfectly choreographed. From speedy Mercury near its heat to icy Neptune far away, and all the dwarf planets too. They all answer to the sun. Its mass dictates the structure of our entire solar neighborhood, a true celestial conductor. The sun is our powerhouse, a constant, reliable source of immense energy and influence. It's been shining for billions of years and will continue for billions more. Understanding it helps us understand our place in the universe. It reminds us of the scale and the grandeur of the cosmos. Our sun, a truly wondrous star.